trolley A of mass 7.2 kgs moves to the right at 0.4 meters per second in a straight line on a horizontal floor. So you just take this as mass 1 and this as velocity 1. Okay, this is what's happening there. It collides with a stationary trolley. Tracer remains still. It's not moving. It collides with a stationary trolley B of mass 5.3 kgs. So let's call this M2. Okay, sharp. So we need to understand the opening statement there. You've got this trolley here that is moving at 0.4 meters per second with that mass and moves towards that one that is still at 5.3 kilograms. It's not moving. So we can take the right direction as the positive and the left direction is the negative. Okay, that's fine. We continue reading. After the collision, the trolleys lock together and move to the right as shown in the diagram below. So once this one collides with this, they lock together and then they move to the right. So that's what they're telling us. So that means now it's basically one object now. So you basically want to add the two masses of 5.3 and 7.2 because it's just one object because they're bound together. So I'm just giving you analysis. And then it says ignore any frictional effects. So they're talking about any form of friction from the floor or air resistance. Okay. Sharp. Question 1 says, state the principle of conservation of linear momentum in words. In an isolated system, total linear momentum before collision equals total linear momentum after collision. If you like, you can say in an isolated system, total linear momentum is conserved. So we already have that definition. 4.2, calculate the magnitude of the velocity of the trolleys immediately after the collision. Okay, so now they want you to find the velocity of like this unit. How are you going to find it? You're going to use the law of total linear momentum, right? You know that momentum, total momentum before collision equals total momentum after collision. What do we mean by that? We mean that the momentum of the trolley A plus the momentum of trolley B before collision, trolley B before collision equals the total momentum of trolley A after collision plus trolley B after collision. Do you guys understand this equation? All of you? Okay. Sharp. You guys understand the formula? So now that is the only thing we're gonna use here, right? So remember the axis to find the velocity of the trolleys immediately after collision. This velocity was basically moving there. So now let's go ahead and substitute. The momentum of the first one is just m1 v1, okay? Then this will be m2 v2, before collision, and then this will still be m1 v1 plus m2 v2 after collision. Let's deal with this one. What is my m1? Let's substitute. What is my m1? What is my m1? Proper stuff. What is my v1? Proper stuff. 0.4 meters. Okay, velocity is just meters. Squared is acceleration, so that's just for 0.4 meters. Yes. What is my m2? What is my m2? What is my v1? v2, sorry. Yes. Why do you say 0? Proper stuff. All of us understand that. That's good. Fantastic. Okay. Equal to after collision now, m1 is still 7.2. Velocity of it we don't know. Let's call it v. Let's call it v. We don't know the velocity. Remember, we're just looking at the momentum when they are bound together, plus the mass of the second one doesn't change till 5.3, then the velocity with which it's moving is still v because they're moving at the same velocity. Do you guys understand that? So this will give us what is 7.2 plus 5.3? Are you guys happy with that 13.5 v? Yes, 12.5. Yes, 12. Yeah, sharp. So now this you could have done like from the word go, like from here. You could have done it from here. Look at this, ne? Since these two things are after collision, they are bound, right? So you should have just said m1 plus m2, ne? And then v1 v like that, and then this will just be 12.5 v because it's just one unit now. It's one object because they are bound. So that one object is of object of 12.5. You should have that. You could have done that at the beginning, but I just didn't do it so that you guys can see what's going on. So just to save time. So in the exam, don't do this. Just go straight to going 12.5 v. Okay. Sharp. So now, can you guys calculate this whole thing for me? Give me like this whole thing. Tell me what the answer is there. This left hand side. Okay, 2,88. Proper stuff. Now remember that you're looking for V and not 12.5 V. So you're going to get rid of this by dividing there so they can cancel. What you do on the left, you must do on the right. So what is 2.88 divided by 12.5? Just press divide by on your calculator because you already have the 2.88. Divide by 12.5. Tell me what you get. 0.23 V. Ne? So your V is equal to 0.23 meters per second. Ne? Now, there's a way we check, there's a way we confirm our answers in physics. We can't be 100% sure that your answer is correct, but you will have confidence. Look at this answer is like, it's a positive answer. Ne? So now it's positive, meaning that it is moving, and we chose right to be a positive. So it means that it's like the objects are moving in this direction. So it confirms, it tells you your answer could be, chances are your answer is correct because it's pointing that the 0.2 positive is heading in this direction. So it tells you that your chances are your answer is correct. So that's another way of checking like how correct your answers are. Yavakala Matiota? Yes. Yavakala. So let's pause this.